lifeless body on the ground. No witnesses, no weapon, just one tiny bullet casing. Could this piece of metal talk? Could it reveal the shooter's identity? What if I told you it can?
Welcome back to Taruvu Forensic Vlogs. I'm Suresh Taruvu, and today we are looking ahead at how tomorrow's breakthroughs are transforming the way we catch criminals. Forensic ballistics represents one of the most crucial and sophisticated disciplines in modern crime scene investigation, providing investigators with powerful tools to connect firearms to crimes, reconstruct shooting events, and identify preparators. This comprehensive field combines physics, chemistry, and advanced technology to extract vital evidence from bullets, cartridge cases, and related materials found at crime scenes. Forensic ballistics is the scientific analysis and interpretation of ballistic related evidence to establish facts in shooting related crimes. The field encompasses the examination of firearms, ammunition, and projectile motion to reconstruct shooting incidents and link specific weapons to crimes. Every firearm leaves unique microscopic marks on the fired projectiles, creating what experts call ballistic fingerprints, marks as distinctive as human fingerprints. The discipline divides into three primary categories. Internal ballistics examines what occurs when the firearm from trigger pull to bullet exit. External ballistics studies the bullet's flight path through air, and terminal ballistics analyzes the impact effect with the bullet strikes the targets. Crime scene investigators begin by carefully documenting the location of firearms, expended cartridges, and potential evidence in the immediate vicinity. Proper photography and videography is also very important. Capture the undisturbed scene with detailed documentation, noting the location, orientation, and position of each piece of evidence. When firearms are present, investigators note their loaded, fired state, and for revolvers, etc. Photograph the cylinder position before handling. Bullet and cartridge case collection. Bullets and bullet fragments are collected individually using clean disposable gloves and placed in separate containers such as pill boxes or coin envelopes. Investigators never mark directly on the bullets themselves. Instead of marking containers with item numbers, dates, case numbers, and collector's initials. Expanded cartridge cases receive similar individual treatment as they contain crucial firing pin impressions and breech face marks unique to specific firearms. Maintaining an unbroken chain of custody is essential for evidence integrity. Documentation must track every person with handles, evidences when transfer occurs and where evidence is stored. This meticulous record keeping ensures evidence authenticity in court proceedings and prevents contamination or loss. Ballistic evidence analysis, microscopic examination. Forensic examiners use comparison microscope to analyze the unique markings left on the bullets and cartridge cases. When fired, the rifling grooves inside gun barrel create distinctive striations on bullets, while firing pins and breech face leave characteristic impressions on cartridge cases. These microscopic marks are compared between crime scene evidence and test-fired samples from suspected weapons. National Integrated Ballistics Information Network (NIBIN) contains over 2.8 million digital images of ballistic evidence that can be rapidly searched to link crimes across jurisdictions. The Integrated Ballistics Identification System (IBIS) captures high-resolution 3D images of bullets and cartridge cases, enabling rapid comparison against previously entered evidence. These systems have confirmed over 75,000 hits connecting different shootings since NIBIN's establishment in 1999. Law enforcement agencies submit ballistic evidence within 24 to 48 hours for optimal database effectiveness. Trajectory analysis and scene reconstruction. Bullet path determination. Trajectory analysis helps investigators determine shooters' positions and reconstructs shooting events. Forensic experts analyze bullet holes to calculate impact angles using trigonometry, measuring the major and minor axes of elliptical bullet holes to determine the angle at which bullets struck surfaces. Modern trajectory reconstruction employs various tools including laser pointers, trajectory rods, and digital imaging to visualize bullet paths. The accuracy of trajectory analysis depends on factors such as the reconstruction method used, angle of incidence, target material properties, and bullet characteristics. Advanced reconstruction technique use. Investigators use spatial relationship between primary and secondary bullet defects to estimate bullet trajectories. The probing method generally provides the best accuracy and precision for most striations, through ellipse and lead in methods may be more effective for low angles impact. Three-dimensional modeling and computer simulations increasingly supplement traditional reconstruction methods. Gunshot residue (GSR) testing and collecting methods. Gunshot residue testing provides additional evidence linking individuals to firearm discharge. GSR consists of burnt and unburnt particles from primers, propellants, and metallic fragments expelled when firearms are fired. Collection methods include swabbing with moistened cotton, tape lifting, and vacuum collecting using fine filters. The most effective collection occurs within the first few hours after discharge, as GSR particles degrade rapidly through normal activities like hand washing. Investigators typically swab the web of the non-firing hand and other exposed areas where residue might accumulate. Presumptive tests like the modified grease test and sodium rhodogenate test provides initial screening. Confirmatory analysis uses sophisticated, including scanning electron microscope with energy dispersed X-ray spectroscopy (SEM-EDX) to identify characteristic elements like lead, barium, and antimony. Modern GSR testing faces challenges from lead-free primers and environmental contamination, requiring increasingly sophisticated analytical approaches. Electrochemical methods and nanoparticles-based detection systems represent emerging technologies for rapid GSR identification. Forensic pathologists examine gunshot wounds to determine bullet paths through victims and reconstruct shooting events. Wounds typically display abrasion rings, inverted edges, and may show soot deposits or muzzle impressions depending on firing distance. Exit wounds are generally larger and more irregular than entrance wounds. Though this varies with bullet type and trajectory, the range of the significantly affects wound characteristics. Contact wounds show thermal effects and may display muzzle impressions, while intermediate range wounds exhibit soot deposits and unburnt powder tattooing. Distinct wounds lack these secondary effects, appearing as clean perforation. Advanced wound analysis helps reconstruct victim positions and shooter locations during incidents. Forensic experts trace bullet paths through bodies, accounting for tissue elasticity, bone deflections, and multiple wound tracks. This analysis proves particularly valuable in distinguishing between homicide, suicide, and accidental shootings. Modern ballistic laboratories employ high-resolution 3D imaging systems that captures minute surface details on bullets and cartridge cases. These digital images provides more consistent results than traditional optical microscopy and enable remote comparison between laboratories. Automated correlation algorithms rapidly identify potential matches from millions of database entries. Integrated emerging AI technologies promise to enhance ballistics comparison, accuracy, and speed. Machine learning algorithms can identify subtle patterns in ballistic markings that might escape human examiners, potentially improving match success rates and reducing analysis time. Challenges from modern firearms. The proliferation of 3D printed firearms and ghost guns without serial numbers present new challenges for ballistic identification. These weapons may lack traditional manufacturing marks, requiring development of new analytical approaches to identify their unique characteristics. Legal and procedural considerations, court admissibility. Ballistic evidence enjoys strong legal acceptance in courtrooms due to its scientific foundation and extensive validation. However, proper collection, analysis, and chain of custody documentation remain essential for admissibility. Court testimony must clearly explain the significance and limitations of ballistic evidence to judge and juries. Quality assurance. Forensic laboratories maintain rigorous quality assurance programs to ensure reliable results. These include instrument calibration, proficiency testing, and standardized procedures for evidence handling and analysis. The National Institute of Standards and Technology (NIST) provides reference standards for ballistic testing to ensure laboratory accuracy. Forensic ballistics in crime scene investigation represents a sophisticated fusion of science and technology that provides investigators with powerful tools for solving firearms related crimes. From microscopic bullet markings to complex trajectory analysis, ballistic evidence offers objective, scientifically sound methods for linking weapons to crimes and reconstructing shooting events. The field continues solving with advances in digital imaging, database technology, and analytical methods. While challenges from new firearm technologies and manufacturing methods requires ongoing adaptation, the fundamental principles of ballistic identification remain robust. Success in ballistic investigation depends on proper evidence collection, advanced analytical techniques, and maintaining rigorous scientific standards throughout the investigative process. As firearm-related crimes continues to challenge law enforcement agencies worldwide, forensic ballistics provides an essential capability for bringing perpetrators to justice and providing closer to victim families. The silent witnesses of bullets and cartridge cases continue to speak volumes in the pursuit of truth and justice. If you are fascinated about the future of forensic science, make sure to like, share, and subscribe to Taruvu Forensic Vlogs for more explorations into tools and techniques that ensure justice prevails. What do you think that next revolution in forensic will be? Leave your ideas and questions in comments. Let us shape the future together. Thank you for watching, and remember,
If you found this episode fascinating, don't forget to like, share, and subscribe to Taru Forensic Vlogs for more behind the scenes crime solving stories.
Jai Hind, Jai Forensics.